Hello everyone. So in this lesson we're going to continue with the overall topic of circles and the specific topic of equations of circles in the coordinate plane. So let's recap real quick. In the previous lesson we learned that there's this general equation for circles in the coordinate plane. So x minus h squared plus y minus k squared equals r squared, right? And remember how this works. Remember, h and k give the coordinates of the center, right? The center of the circle, so hk, and then r is the radius of the circle. So here's a specific example. So in this example, h is 4, right? And then we have a plus 6 here, even though the general equation is minus k. So this means k is negative 6, right? We're doing minus a negative 6 to get plus here. So then h and k, the coordinates of the center for the circle would be positive 4, negative 6. And then 9 is r squared. So then the radius, we would square root this to get the radius is 3. 3 squared is 9, so 3 must be the radius, right? And then our circle would look like this. That makes sense? Let's see, the center, right 4, down 6, right? 4, negative 6. So there's the center, and then the radius, right? 3 units there, or there, right? Anywhere in the circle, we should find that the distance from the center to the outside of the circle is 3. And that's how the equation of a circle works. But now let's quickly talk about some weird cases. So here's the general equation again. And again, in general, this is what your equation is going to look like. But here's a strange case. What's going on here? We got x minus 4 squared plus just a y squared equals 9. So the question is, well, what happened to the parentheses and the minus k in this specific example? Right? There's no number being subtracted from y. So what's going on in this case? The reason y is by itself is in this case, k must have been 0, right? We must have gotten y minus 0 here. But if you're subtracting 0, we don't really need to write that, right? Because subtracting 0 doesn't do anything. So this really means, okay, y minus 0 squared. And so the center for this equation is positive 4 for x, right? And then 0 for y. So the center of the circle given by this equation would be 4, comma 0. And then the radius would be 3 still. Here's another specific case. So here we've got y, the y part looking normal, but then the x part strange, right? The x is by itself. And, again, it's similar to the previous problem. What's really going on with the x is that it's actually x minus 0 squared. And we don't really need to write the minus 0. We can just write x squared by itself, right? This goes away, and that's just x squared. And again, the center for this particular circle would be 0 for x, and then y plus 6 means negative 6 for the y, right? So again, the center is at 0, negative 6 for this circle. Or what if both x and y are by themselves? So like this, right? Well, that means it's x minus 0 squared there, y minus 0 squared there. So this represents a circle with center 0, 0, as in it's a circle with the center at the origin. So if we sketched it, right, the circle given by that equation, the center is literally at the center of the graph, right, at the origin at 0, 0, and then the radius is 3. So you get a circle with radius 3 centered at the origin. So that is all that's going on with those y squareds, those x squareds. Now let's go over a couple of examples involving equations of circles. And this example says, what is the equation for the circle whose center is 5, negative 3, and which contains or goes through the point 7, 1. So first of all, take note what they're asking for. They're asking for an equation of the circle they're describing, right? And we know what an equation of a circle should look like. So here's the general form of it, right? But now notice that they're giving us the center. The center is 5, -3. So that's good. That gives us h and k. But notice that they haven't said anything about the radius. They're not giving us the radius. So, well, let's first start by filling in what we know. So x minus, and then h is +5 plus y minus -3 will make this +3 squared equals r squared. And again, we still don't know r. Now they are giving us some other info. The circle goes through the point 7, 1. So let's just sketch this, okay? The center is at 5, -3. So I'll write 5 down 3, so here. And then it's saying the circle goes through the point 7, 1. They're giving us one of the points on the circle itself, here. So if you think, that's like a circle that kind of looks like this, right? Okay, looks like that. That's not very precise, but still. Now, if we did draw this precisely, you would find that the radius here is actually not a clean number. So our task then is to do something so that we can figure out what this r should be. And again, it's going to be some strange number. Well, so what can we do? I mean, they don't give us the radius, but they do give us this extra info about 7, 1, right? This extra point. So if you think about it, any point on the circle, what this equation means is any point on the circle should satisfy this equation, as in make this equation true when we plug it into x and y. How these equations work is this equation needs to be true for every point on the circle. So what we do then, this point is an x-y pair that's supposed to satisfy this equation, right? So we should be able to plug in this 7 for x here, and this 1 for y here. And our equation still holds, our equation still works. And when we do plug in, what happens? I'm going to rewrite what we have here. But then for x, we're replacing the x with 7, right? We're plugging in 7. And then the y, we're replacing with the y value of the point 1, right? And now what do we have? We have one equation with one variable over here, but then the whole left side is just numbers. We can figure out what the left side, that entire side, evaluates to, right? It's going to be some number. And so in this case, we can actually solve this equation for this one variable. Because look, what's 7 minus 5? That is 2, right? This becomes 2, but don't forget it's being squared. Plus, what is 1 plus 3? That's 4, right? And again, don't forget it's squared. And then equals r squared, that's the right side. And then going further with the left side, 2 squared is 4, plus 4 squared is 16, equals r squared. And then left side, 4 plus 16 is 20, equals r squared. And I think I'm running out of space, so let's move this over here. 20 equals r squared. And now, how do I get r by itself? Right, how do I solve for r in this case? How do I get the squared away? I square root both sides, right? So square root and square cancel, and I get r by itself equals square root of 20. So basically, r is square root of 20, which is around, it's a strange number. In a calculator, we get around 4.4721. So again, that's the radius. The radius is some weird non-integer number. If we drew this circle over here precisely, we would find that the distance from the center to the outside is around 4.47, right? That weird number. So we found what we're looking for, except remember, that's not what the problem is asking for. That's not our final answer. What is the problem asking for? It's asking for the equation of the circle. So our final answer is an equation into which we need to plug this into the right spot, right? So let's clear this up. So here's the general form of the equation again. And again, we know h already, 5 squared. We know k, it becomes plus 3. And earlier we didn't know the radius, but now we figured that out, right? We can plug in the radius we found, around 4.4721 squared. And if you keep all the digits here and square it, you will find the equation becomes, so all this, again, if you keep all the digits, you square it, you will get just a clean 20 on this side. And now we've plugged in h, k, and r. This is our final answer. That is the equation that gives us the circle they're describing. And by the way, when we're talking about the equation of a circle, keep the x and the y as variables for your final answer. And another quick thing, another way we know that this should be a clean 20 after it's squared is because instead of plugging in 4.4721, we could also have plugged in this thing in like a radical form, right? We could have plugged in root 20 here, and then the square root and the square cancel, right? Squaring a square root, those undo each other, and so we get back a clean 20. So that is a way to find the equation of a circle given its center and a point on the circle. So here's another example, our second and final example. And this is another problem where they're describing a circle to us and they're asking us to come up with an equation for that circle. So it says, what is the equation of the circle whose center is 4, 3, and which is tangent to the line x equals -2? So again, they're giving us the center like in the previous example, but what does this tangent thing mean? Now it has something to do with this line, x equals -2, and remember what that means. X equals, and x equals line is a vertical line, right? So at -2, that would be like a line here, perhaps, right? In the coordinate plane. But what does that tangent mean? So, tangent. Well, when two things are tangent to each other, that means they're hugging each other. So like a line hugging a curve, for example, so that they touch at just one point there. So if a line is tangent to a circle, that line is just hugging that circle so that the line touches the circle at just one point there. So what am I talking about? So here we've got a circle, and let's talk about lines relative to the circle, right? Now let's say you have a line out here. Well, where does that line intersect with the circle? It doesn't, right? So there's 0 intersections. But then what if we have a line going straight through the circle? Now how many places does it intersect? 2, right? Here and there. So the previous line and this current line intersecting at two points, those are not tangent to the circle. So a line that is tangent to the circle then would be situated just so that the line and the circle are only touching at one point, and it's kind of hard to draw by hand, but only at one point and nowhere else nearby. So again, this line and this circle are tangent. They're just touching at one point. So going back to our example then, what is the equation of the circle whose center is 4, 3, and which is tangent to the line x equals -2? Now, first of all, know that we're just going to stick to examples where it's easy to figure out with a sketch. And so let's do sketch it. Let's see, the center is 4, 3. So starting from the origin, right 4, up 3. It's just going to be a rough sketch. There's no grid lines, but somewhere around here perhaps. That's the center of the circle. And then this circle is going to be tangent, just touching the line x equals -2. And again, where was this line again? X equals -2. So that's a vertical line, let's say around here, right? And don't forget, if this was y equals, then it would be a horizontal line, right? So now, the circle, the center is here, and do you see how if the circle is to just touch this vertical line, if the circle is to be tangent to the vertical line, then the circle is going to have to be tangent like here, right? Directly to the left of the center. And then this is the distance of the radius, right? And the circle would look something like this. Again, very rough sketch, but it'll still help us figure the problem out. Do you see how the circle is indeed tangent to that line? So here's the line, and then the circle is just hugging or just touching that line at this one point here. So here, let's fill in what we know first. So here's the general form of the equation again, and h is 4, k is 3, equals, and again, we're left with an unknown radius, right? So to find that radius then, we really have to figure out what's going on in our sketch, and we have to visualize the situation. So here, the center is 4, 3, right? Right 4, up 3. And then this line is x equals -2. So from like the 0 line, we're going left 2, right? And do you see how the distance from the center to the point where the circle is touching the line, that distance is the radius of the circle. And if you think about it, we know that distance because from the center, we're right 4, right? Then we go back 4 to get to 0, and then we go 2 more to get to -2. So what's the distance there total then? We went 4 and 2. So the total distance there is 4 plus 2, 6, right? So from our sketch then, we just figured out, okay, the radius is 6, and we're done, right? Or we could do the squaring of the radius here. So our final answer then is all this that we had already on the left side, and then equals on the right side this radius that we found, 6 squared. 6 squared is just 36. And we're done. We found this equation that defines this circle that they're describing with center 4, 3, and which is tangent to the line they're giving us, x equals -2. So that's it for this lesson. As always, good luck.